thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Hello everyone, thank you for joining us for week 40 of the Oxygen Concentrator Talk Call, brought to you by the Oxygen Alliance. My name is Mwabe Lungu and I'm currently in Lilongwe, Malawi, and I'm picking up the hosting duties from Sharon, who has gone out to the field. So she has gone to Neno District Hospital, where she will be conducting a training on concentrator use and assessment. So I'm joined by my colleague, Cynthia Chikomoni, along with our usual technicians from OpenO2 and Sunrise. On the technicians panel today, we have Masofa Mujaji and Paulina Mohosho joining us from Johannesburg, South Africa. And we have Naomi Langizo, Kelvin Saidi, and Eunice Msiska, together with Linda Mission, joining us from Lilongwe, Malawi. And in case it's your first time joining us, the Concentrator Talk Call is a virtual meeting that we host every Thursday from 2 to 3 p.m. Central African Time. And here we discuss the different aspects of concentrator assessment, use, and maintenance. So if you have any issues with your concentrator, we always encourage you to get in touch with us through our email address, info@oxygenalliance.org. And our technicians will do their best to help you out with the right solutions. So on the call, we also normally have a topic of interest, and today we'll be talking about how to reduce noise in oxygen concentrators. So if you also happen to have any questions during the call, you can either just paste it in the chat, or you can just raise your hand and then come off mute and ask your question, and our technicians will try to help you out with the answers. So now let's dive into our questions for today. So our first question says, what is the use of the spring which is found inside the sieve beds? So I'm going to ask Eunice to respond to this one.
Thank you very much, Maui. So all sieve beds that you come across will have a spring fitted inside them. The sieve bed will have a bottom filter, a layer of zeolite up to a certain height, then covered with a top filter. After the top filter, there is a spring, and that spring is compressed and covered with an end cap, which may be held together in place with screws or a nut, depending on the design. As you can see in the graphics, the arrow is showing the spring that you are going to find in the sieve beds, and this is the spring that is compressed. So to answer your question, the spring helps to compact the zeolite and also hold the zeolite in place so that the zeolite doesn't move around during the pressurization process. It is necessary to have the zeolite compacted and not moving about anyhow, as that would lead to a drop in purity. When the zeolite is not compacted, it leaves room for air along with nitrogen to pass through some open spaces, and hence some nitrogen will not be absorbed by zeolite. So this process will lead to a drop in your purity. It would be challenging to perfectly compress the zeolite without the spring. So the spring provides a simpler solution to the problem. Thank you very much.
Thank you very much, Eunice, for that response. I hope that will now help you to get a better understanding of why we have spring inside the sieve beds. So it's very important to have that one there. First time I was working with sieve beds, I didn't know that they fit a spring in there, and when we were trying to open up the sieve bed, the end cap almost jumped off. So yeah, it can be dangerous if you don't know that there's a spring inside, because it sometimes gets it has some particular force that can send the end cap flying. So yeah, thank you very much, Eunice, for that response. So we'll now jump on to our second question, which says, when I opened up the sieve beds of a J5 oxygen concentrator, I found that the bottom part of the bed had some relatively larger in diameter zeolites. I wanted to know the purpose of the larger diameter zeolite and if I could refill my sieve beds without this type of zeolite. So I'm going to ask Paulina to respond to this one.
Thank you, Mwabi, for the question. The J5 sieve beds have some larger in diameter zeolites placed at the bottom and are separated from smaller in diameter zeolites by a wire mesh. The purpose of these larger in diameter zeolite is to absorb water, which may condense. The compressor gets hot under normal operation. As it gets hot, it also warms up the air it is compressing. Compression also makes the air heat up. Air being pulled in by the compressor contains water vapor, and as this air is cooled, the water vapor condenses, forming liquid. Water affects the performance of the zeolite as the zeolite gets saturated with water and will not perform its function, which is to remove nitrogen. So in order to prolong the life of the zeolite in the J5 models, the manufacturer opts to use these larger types of zeolites, which serve the purpose of absorbing the water. If you do not have the larger diameter zeolite, you can replace the zeolite inside the sieve beds with a small diameter zeolite and you will get the desired performance from your oxygen concentrator. The only problem the only problem that you would risk it's getting the zeolite contaminated with water faster than it was before. Thank you, Mwabi.
Thank you very much, Paulina, for that response. I hope that has answered your question. So for me, I've only seen this type of zeolite in the GF5 commonly. And also the AirSep model. They sometimes place it in the product tank, but it's a slightly different from how they're using it in the J5. So yeah, thank you, Paulina, for explaining to us why we have that zeolite in there. Right. Unless if we have any questions, maybe before we move on to our next question. Okay, no question there. So we'll be moving on to our next question, which says, does an oxygen concentrator have a lifespan? If it does, are there any ways to prolong the usage period of the concentrator? So I'm going to ask Kowinda to respond to this one. Apologies, Kowinda, I forgot to introduce you at the beginning of the call. Yeah, so over to you.
Thank you, Mavi. So my name is Kulvinder Singh. So I am from India. As working as a service manager in India, I am with Sunrise from last 7 years, working with stationary, portable, all the oxygen concentrators. Nearly worked on AirSep, Invacare, uh, OxyPure, and OxyFlow, Inogen, O2 concepts, all this. Okay. So coming on to the answer, so oxygen concentrators are complex machines that require frequent maintenance by qualified technicians, oblique engineers. Most portable oxygen concentrators last between 4 to 7 years, and most manufacturers indicates that the average device life is about 5 years or 10,000 hours, mainly based on molecular sieve life. An oxygen concentrator can easily reach 40,000 working hours or more when it is regularly serviced and taken care of. Concentrators, just like any other medical equipment, need to be handled with care and taken care of. Make sure the concentrator's housing is cleaned with a soapy damp cloth. Inspect the concentrator's filters every week. These are the gross particle filters and the intake filters. Gross particle filters are washable. Wash these at least once a week if in a very dusty environment, and replace when completely dry or whenever necessary. Change the intake filters when necessary. The seabeds contains zeolite. which is a sieve for oxygen. The service life of molecular sieve is based on the quality of the air intake. Molecular sieve loses its efficiency over time and humidity and is one of the reasons. When water enters the seabeds, it condenses in the filters and clogs the granules. This will result in low concentration, highly system pressure, just to mention a few. So when this is encountered, the beds need to be replaced. If one seabed is performing better than the other, both beds are to be replaced at the same time. So it should be noted that sieve filters are sensitive to humidity. When moisture enters the filter material swells up, clogs the filter, and the oxygen cannot pass through anymore. So when this happens, the filter have to be replaced, which is often not economical. So this is a big problem, especially in coastal areas where the humidity of the air is very high. This solution is simple for concentrators that are stored in hospital storage rooms waiting for a shortage in the wards have to run even when not in use. So we can say more the use of the oxygen concentrator, the long is the life. The shorter the use, the shorter the life. So when the concentrator runs, the filters get flushed together with the humidity. Never use a concentrator without filters. Don't ever fill the humidified bottle fully and make sure all oxygen accessories are thoroughly cleaned and take care of it if not in use. When the concentrator is powered on, listen attentively to the opening sound, especially the pumping and the exhausting sound. So it varies. So pay close attention to any unfamiliar sound and always check out what the cause might be. So it is better to use a stabilizer to minimize the power fluctuation problems with the oxygen concentrators. Thank you.
Thank you very much, Kowinda, for that response. That was a lot of well-detailed information in that question. So I hope that will help you to now probably manage your oxygen concentrator. So if we have any questions or comments regards to the response that Kowinda just gave us, we can raise our hand or you can just come off mute and then we discuss. Okay, it seems we don't have any questions there. So we have a poll at the end of this question, and I am going to launch the poll. So the poll says, do you understand the importance of taking care of the oxygen concentrator to elongate the lifespan of the equipment? So I'll leave the poll open and then people can vote. So for those of you who are not aware on how you can access the polls, if you're joining us from your computer, if you go to the far right, the icon on the far right of your screen, that's the activities button. If you click on that one, it will open up a window where the pause menu is one of the listed options. And if you're joining us from your mobile phone, then hit on the menus option on the bottom right of your screen. It will bring up a window where the pause the activities button is one of the listed options. If you click on the activities button, that's going to take you to another window where you have the pause menu listed. Okay, it seems our responses are in and most of us now are able to understand the importance of taking care of the concentrator so that we lengthen the lifespan of our machine. So I am going to end the poll now and we will now jump on to our next question. So the next question says, hi, I am working on a Longfian J5 concentrator which has run for less than 1,000 hours. The concentrator is producing low oxygen purity of 78%. When I open the covers of the concentrator to assess the concentrator's inside, I discovered that there was a leakage on the copper pipe just close to the aluminum fins on top of the metal casing of the compressor. I tried to seal the leak with an adhesive, but the pipe is still leaking. What can I do to solve this problem? Is it okay to just replace the copper pipe with any other pipe, for example, a hose pipe? So I'm going to ask Eunice to respond to this one.
Thank you very much, Mwawi. So every concentrator that you're going to come across has a cooling system, and it includes the cooling fan, which helps to cool the compressor, and some concentrators such as the air safe concentrators. In addition to the cooling fan, they also consist of coiled aluminum pipe connected on the compressor exhaust port. The function of the fan is to cool the compressor and the whole unit. The temperature and pressure of the air which has been compressed increases, so the coiled pipe is there to help cool the compressed air before it reaches the sieve beds. In Longfian J5, the cooling system is made up of a fan which blows air towards the compressor and the copper pipe, and aluminum fins which cools the compressed air. You can solve this problem by either soldering the copper pipe using a copper rod to fix the leakage, or you can seal the leaks using a high performance adhesive that can withstand high temperature and high pressure, such as epoxy. So epoxy is formulated to set hard and bond well with most metals. In order to use epoxy to fix the leak, first of all, you will have to clean the area around the leak. Make sure there is no dirt, rust, or paint. You can use a wire brush or a fine sandpaper to clean the area. Epoxy comes with two tubes with different color codes. So just follow the mixing instructions on the manual that comes with the adhesive for you to apply the adhesive correctly. After you have applied the epoxy, do not switch on the concentrator. Wait for the epoxy to completely dry. The manufacturers of different concentrator brands designed specific cooling systems that work with those particular concentrator models. The J5 was designed with aluminum fins and coiled copper pipe to help with the cooling. So replacing the air cooler in the J5 concentrator with a hose will not work. So I recommend you to look for a J5 concentrator which you can scavenge parts from, and you should get the air cooler from that concentrator to replace the broken one. Thank you very much.
Thank you very much, Eunice, for that response. I hope that was well detailed enough, and you now know what to do on your machine. So just follow the steps that Eunice has given to you, and then you should be able to get your machine back and running. So if we have any questions, we are free to ask those questions. If we have any further comments from the other technicians, we are also free to do so. And while we wait for those questions, we also have another poll at the end of this question. So I am going to launch that poll now. So our next poll says, have you ever used an adhesive to seal a leakage in an oxygen concentrator before? So I'm going to leave the poll open for a few seconds and then people can vote. Okay, our votes are coming in, and seems like most of us haven't used this adhesive before. But yeah, as Eunice has explained, the epoxy is the best to use. Some of these glues that you might use don't really do such a good job, but if you use the epoxy, they work well for wood, for plastic, so they will help you to get the job done. All right, so I'm going to end the poll now and we'll jump on to our next question, which says, hello, I am a biomedical technician at a certain district hospital. While servicing the compressor, I noticed that the reed valves on the compressor were broken. I have never replaced the reed valves and I wanted to know the steps to follow when replacing them. So I'm going to ask Kelvin to respond to this one.
Thank you, Mwawi. So flapper valves, also called reed valves, are a type of one-way valve that are found on the valve plate, which allows air to flow into the cylinder sleeve or from the cylinder sleeve outside the cylinder sleeve. And just as any other type of valve, the flapper valves will give passage to the air and they will block air from escaping. So since flapper valves are located inside the compressor, when you want to replace the valves, you are supposed to dismantle the whole compressor and make sure you carry out the process of dismantling very carefully. Below are the steps required to follow. So the first thing you have to do is to remove the 8 screws that hold the compressor heads in place. When removing the heads, you need to be sure to keep each head and its components with the correct compressor side. After that, check for proper placement or damage to the gaskets on the bottom of the compressor heads. If they are damaged, you need to replace them. So the compressor flapper valves should be flush with the valve plate. This means that there shouldn't be any spacing between them. If the valve is broken or it is not flush with the valve plate, or foreign matter is detected inside the head, you need to clean or replace the compressor flapper valves. After that, remove the screw holding the compressor reed valves in position and the valve plate, and you have to discard the used flapper valves. Now position the new flapper valves so that they are centered and completely cover the holes in the valve plate. The last thing you do is to place the metal retainer on the reed valves or flapper valves and secure it with the lead valve screw. And then finally, you can close up your compressor and test it to see how it is performing. Thank you. Over to you, Mark.
Thank you very much, Kelvin, for that response. I hope that has helped you to understand how best you can do that. So we also have a video on our website which talks about how you can disassemble and reassemble an air compressor. So in addition to the explanation that Kelvin has given us, you can also go on our YouTube channel, just go under the maintenance videos, and you should be able to find that video that will also give you. And the good thing about the video is you'll be able to see now how each component is laid out inside. So that will give you further help on how best to approach this. So you can also find that video on our website, oxygenalliance.org. So if you go there, you'll be able to find that. All right, so if we have any questions for Kelvin with regards to the response he has given us, we are free to do so. Okay, no questions. Moving on to our next question. So the next question says, hello, I am a biomedical technician at the district hospital. We have 3 Devilbis 525 oxygen concentrators. One of them is not giving an audible sound when there is a power failure. What can be the problem? So I am going to ask Masofa to respond to this one.
Thank you, Mwabi. The Devilbis 525 oxygen concentrator comes with a 62 dBA alarm sound system. This alarm is responsible for alerting the user whenever there is a power failure, low purity, or low or high pressure or overheating of the oxygen concentrator. It is very important to have a working alarm system in an oxygen concentrator because whenever there is a fault with the concentrator, the user has to be alerted so that necessary measures are taken. The alarm system is incorporated on the printed circuit board and is connected in a microcontroller on the PC board, on the PCB, which is responsible for sending out different error messages depending on what is being read from the sensor. The sensor detects changes in the system and send the data to the microcontroller, which in turn commands the buzzer to sound or not, depending on the change. The low purity LED is turned on when the purity of oxygen falls below 85%, but still above 75%. When the purity further falls below 75%, but still above 60%, both the low purity will turn on along with the beeping audible alarm. When the purity falls below 60%, the red service light and the beeping will turn on. The power failure alarm is triggered when the machine has been disconnected from the power supply and the switch is in the on position. To make sure that the alarm is working perfectly, take the following steps. Connect the oxygen concentrator to AC power and then the power switch on. Allow the device to run for several minutes. With the power switch on position, unplug the AC power cord from the outlet. The alarm condition audible beep should occur and continue to alarm for a minimum of 120 seconds. Take note that there is no visual indicator that for this alarm condition. Reconnect the AC power cord and confirm the alarm condition ends. Unlike other models, oxygen concentrators are like the air sieve that comes with 9-volt battery to power the alarm. The DeVilbiss 525 concentrator do not come with a battery. Instead, they use a capacitor on the PCB to power the alarm system. And if the concentrator stays for too long without use, this capacitor might get discharged and thereby not being able to power the alarm. It's the capacitor is that one shown on the image. You can test if the capacitor is fine using a multimeter by desoldering it from the PCB and setting the multimeter to read in the high ohms range, somewhere around 10K. Touch the multimeter leads to the corresponding leads on the capacitor. Read the red to positive and black to negative since the capacitor is polarized. The multimeter should start at 0 and then move slowly towards infinity. This means the capacitor is in working condition. If the meter stays at 0, the capacitor is not charging through the battery of the multimeter, meaning it is not working. To check for the capacitance, you should use the capacitor meter. If you find that the capacitor is dead, then you need to replace it with the capacitor of the same capacitance value. The capacitor is 1 farad and 5.5 volts. The steps outlined above are enough to solve your problem. Thank you, Mwabi.
It seems Maui has lost connection. So I believe now it's time for the topic of interest. So Linda, if you're ready, just you can start explaining the topic.
Okay, thank you, Kelvin. Our topic of interest today is how to reduce noise from oxygen concentrators. So, noise is an unwanted sound that is regarded as loud, unpleasant, or disruptive to hearing, and there are several levels of noise. For example, a nearby whisper is about 30 decibels, a normal conversation is about 60 decibels, and a noise above 70 decibels over a prolonged period, if exposed to it, it may start damage your hearing. And also, if you are exposed to noise of a level above 120 decibels, it can cause immediate harm to your ears. So different brands or models of oxygen concentrators produce different levels of noise. So in the graphics, the table just shows different levels of noise for different brands of oxygen concentrators, just a few of them. So it shows that for AirSafe Intensity or Elite, Devovis 515 and 525, they have the same noise level, which is 48 decibels. And for J5, it is less than or equal to 50 decibels. And for Foley, it is less than or equal to 60 decibels. So, impacts of increased noise level from oxygen concentrators to the patients. One might wonder why we are talking about the noise produced by oxygen concentrators. If the noise level of your concentrator go beyond the intended level, it may imply that something is wrong with your concentrator. And also, this high noise from oxygen concentrators can have an impact on the patients. It can cause stress, anxiety, depression, high blood pressure, heart disease, and sleep disturbances for the patients in the ward. Therefore, it is important to make sure that oxygen concentrators are in good shape and are not producing any unusual noise. So what causes the noise levels to increase in oxygen concentrators? There are several factors. One is broken shock absorber. Different models of oxygen concentrators have either rubber shock absorbers or spring shock absorbers for their compressors. For example, in the Devovis 515 and 525, as seen in the graphics, they are mounted on rubber shock absorbers. And while in J5 oxygen concentrator and air safe concentrators, the compressors are mounted on spring shock absorbers. So as it can be seen in the graphics, and all the vibrations that are produced on as the compressor is wet are absorbed by this. So, however, these rubber mounts or the springs, they break or degrade with time. This is due to internal heat and repeated usage of the concentrators. And the shock absorbers can also be damaged when repairing the compressor. When doing compressor repairs, the compressor needs to be removed from the concentrator by removing the nuts holding it. And some absorbers get broken during the tightening of these nuts. The compressors begin to make hissing and cracking noises that are irritating to bear if a concentrator with broken shock absorbers is used for a long period of time. So the images in the graphics again are showing different shock absorbers in three concentrator models. That is the Devovis 515, 525, and a spring in air safe concentrator. Another cause for increase in noise levels in oxygen concentrators are loose screws and internal components of the concentrator. There are times when screws are not tightened all the way after the concentrator has been serviced. The vibration produced by the concentrators can cause these screws to get loose, and this in turn cause an increase in the noise level since the components can be hitting each other and also can be hitting the casing of the concentrator. And data filters can also cause an increase in the noise level in oxygen concentrators. When the filters, such as the intake filter and gross particle filters, get clogged with dirty, the pores on the filters are reduced in size, and air is forced to pass through the filter, which produces a hissing sound, and this causes an increase in the noise level. So the image in the graphics It shows different filters. That is, there's a bacteria filter, gross particle filter, and also an intake filter, which are used in oxygen concentrators of different models. And also absence of a muffler and a resonator can cause an increase in the noise level in oxygen concentrators. The concentrator has two mufflers. We have the intake resonator and the exhaust muffler. The intake muffler is connected to the intake port of the compressor, and it minimizes noise from compressor suction as air enters the compressor. And the exhaust muffler is connected to the waste solenoid valve. That is, if your concentrator uses solenoid valve blocks, or to the exhaust port of the rotary valve. And on the other hand, we have the exhaust muffler. Its function is to reduce noise of nitrogen-rich air which is discharged from the sieve beds in the concentrator to the environment. If these two mufflers are not available in the oxygen concentrator, or are not connected properly, or they are broken, then a loud noise will be produced by the oxygen concentrator. And also, worn out compressor service kits can also cause a rise in the noise in oxygen concentrators. The compressor is one of the main components in an oxygen concentrator, and a compressor that is worn out or defective, its output pressure, which is required for the nitrogen adsorption process in the sieve base, decreases, resulting in low oxygen concentration. And the compressor, which is typically used in oxygen concentrators, is double-headed, oil-free, and it is secured to the unit on the base via shock absorbers and 4 motor mounts. And in addition to producing low pressure, which results in low oxygen purity, when the piston caps and cylinder sleeves inside the compressor are worn out, the compressor produces squeaking loud sound. This is because the cap retainer inside the compressor may be hitting the sleeves as the piston is moving up and down. And sometimes the squeaking sound may not be there, but the sound of the compressor usually changes, and it is loud when the service kits have worn out. Therefore, it is important to check the status of the compressor and service it when the concentrator has run for a certain period of time, and you have to know. And if you haven't changed anything, or the noise has changed in the concentrator, the service kits may be worn out. So let's just make sure that we pay attention to the sound which is being produced by the concentrators. So in the graphics, the images just show some of the components that are found inside an air compressor in oxygen concentrators. So now let's go in, look at how we can reduce the noise being produced or the increase of noise in oxygen concentrators. So there are several ways on how you can reduce this noise. The first way is to replace broken shock absorbers. If the absorbers are broken, you have to replace the damaged absorbers. You can either scavenge the absorbers from old dead oxygen concentrators, or you can purchase new ones. And secondly, is to tighten the screws that hold the internal components of the concentrator. So whenever you are working on an oxygen concentrator and you are done servicing the concentrator, make sure that all the screws that hold the components inside the concentrator are tight enough in order to reduce the noise that may arise if the compressor or any other components are hitting the case of the concentrator. And also, if you have noticed, some concentrators, almost many modern to reduce the noise. So if your concentrator has no pads or inside their covers, you can either replace the covers, you can scavenge for the covers with pads and replace them as in order to reduce any noise that may be coming from the compressor. And also you have to make sure that the sieve beds are secured in place while we're using cable ties so that they shouldn't be moving around when the concentrator is in operation. And also you can fix the noise being produced by a concentrator with a muffler. As we are all aware that oxygen concentrators come with mufflers fitted inside, and they can start making noise if the mufflers are broken or if the muffler is not there as explained earlier. And this problem can be solved by just replacing the muffler with a new one or scavenging from outdated oxygen concentrators. And also, the other way to reduce the noise being produced from oxygen concentrators is just to keep your filters, the intake filters and the gross particle filters clean. If your concentrator contains reusable filters that are washable, you have to clean them frequently in accordance with the directions in the user manual. And if your oxygen concentrator happens to have non-reusable air filters or intake filters, you have to check regularly. And then if they are dirty, you have to replace them every 6 to 12 months. And finally, is the other way to reduce the noise is to service the compressor. So if you notice that your concentrator is producing some squeaking sound, or the sound coming from the compressor is louder than before, you have to service the compressor. You have to change the cylinder sleeves and the caps and make sure that everything is as it was before. Thank you. My offer to you.
Thank you very much, Linda, for that topic of interest. I hope I've managed to pick up a few things from what Linda has just gave us. And if we have questions with regards to the topic that she has presented to us, we are free to raise our hand and ask, or we can just paste it in the chat and then I'll read it out. Okay, it seems we do not have any questions there. My apologies, lost connection for a minute there, so I jumped off the call somehow. But now we are back. Okay, so looking at our time, we still have a couple of questions. We'll try to cover as much in the time that is remaining, and we'll see how far we get. So our next question says, if an oxygen concentrator purifies the air to produce a higher concentration of oxygen, why is it that we get only 95.6% at the outlet and not 100% oxygen? So I'm going to ask Naomi to respond to this one.
Thank you very much for the question. First of all, we need to understand that the composition of the atmospheric air. So we have approximately 78.08% of nitrogen and 20.95% of oxygen. And it also contains a small percentage of other gases, that is about 0.97%. These gases include carbon dioxide, neon, and hydrogen. So the function of an oxygen concentrator is to clean the air so that we can have a higher percentage of oxygen remaining. This is made possible through the principle of pressure swing adsorption, PSA. So in PSA system, a molecular sieve material called zeolite is used. Zeolite has an important property that is used when separating the gases. So at a higher pressure, it traps nitrogen and lets other gases to pass through. And at a lower pressure, it releases the nitrogen. Since zeolite only removes nitrogen from the air and allows the other gases to pass through, it is not possible to get 100% oxygen from the outlet of an oxygen concentrator. That is to say that the air passing through the zeolite material is a mixture of oxygen and the small percentage of other gases that is not nitrogen. So the percentage of oxygen produced by an oxygen concentrator can be calculated by simply subtracting 78.08 from 100, and that will give us 21.92, of which 20.95% is oxygen and 0.97 is a composition of the other gases. Therefore, the percentage of oxygen can be found by dividing 20.95 by 21.92, and then we'll multiply the answer by 100%. So our result will come up to 95.6% if the calculations are done right. Thank you, and back to you, Maui.
Thank you very much, Naomi, for that response. I hope now we understand where the 95.6 comes from. The other thing that will probably get you to that is the type of oxygen purity sensor you are using. Normally, if you're using an ultrasonic oxygen sensor, then it will also only go up to 95.6. So you could have an oxygen supply that might be able to give you purities greater than 95.6, but then if the type of sensor you're using is ultrasonic, then you'll still be limited to these readings. So thank you very much, Naomi, for that response. So we have a poll at the end of this question, and I am going to launch that poll, and then we'll give it a few seconds for people to vote. Okay, our votes are in, and it seems most of us are now able to understand, so which is a good thing. So thank you very much, Naomi, for that response, and I am going to end the poll now. So we'll now jump on to our final question of the day, and the question says, hello, I was looking into how long zeolite in a concentrator is supposed to last. The literature I looked at said it takes 6 to 12 months. I've worked on concentrators that needed zeolite even before 6 months had passed since refilling. What is the reason for this difference, and how can I prolong the lifespan of the zeolite? So I'll ask Kelvin to respond to this one.
Thank you, Mwawi. So zeolite will mainly lose its effectiveness as a result of exposure to moisture and foreign particles like dust, for example. So it is therefore important to prevent moisture and these particles from coming into contact with the zeolite if you want to increase its lifespan. So while some reasons for the shorter life expectancy you have experienced are unavoidable, others are not. So I'll outline the causes of this short life expectancy, and at the end, I'll outline ways in which you can prevent the shorter lifespan. So the first cause of zeolite losing its effectiveness quickly is when a concentrator is running in a humid environment. So the compressor pumps will pump the humid air, which is moist, into the sieve beds, and as time goes by, the moisture will contaminate the zeolite, and it will reduce its effectiveness. Another cause of this could be when you're operating an oxygen concentrator. When you're operating an oxygen concentrator, some pipes may break and become disconnected because of the high pressure. So these leaks will allow outside air to enter the pipes, and the air will occasionally reach the sieve beds when the concentrator is not in use or it is turned off. So this will also cause the zeolite to become contaminated and therefore shortening its lifespan. Another cause to the shortening of lifespan would be the concentrator model you're working with. So we have some other concentrator models that do not have a final one-way valve after the bacteria filter on the patient's outlet. So if you land this concentrator with a humidifier bottle, some of the water in the humidifier bottle may end up moving up the pipes to the product tank and eventually reach the sieve beds. So with these causes, I'll now tell you the steps you can take in order to preserve the effectiveness of zeolite. So the first thing you can do is when you're troubleshooting, if you have any disconnected pipes, you need to make sure you seal those openings if they lead to the sieve beds. Okay, so you do this to avoid the moisture from entering the sieve beds. An example would be when you're working with the product tank, the rotary valve, or the solenoid valve. Another thing you have to make sure is make sure that the filters are always clean, and you should never operate an oxygen concentrator without them. So the reason for this is that if a filter is clogged with dust and the compressor is running, some of the dust may find its way into the piping system and it will reach the sieve beds, which will lead to zeolite contamination. And it also goes without saying that if you don't have the filter, then dust will just flow through the pipes to the sieve beds. So either of these two will also lead to contamination of the zeolite. So you need to make sure the filters are always clean and never run a concentrator without the filters. The last thing you can do, if your concentrator model does not have the one-way valve, you have to install it after the bacteria filter. This will be done to avoid the water from entering the piping system. Thank you. Over to you, Mal.
Thank you very much, Kelvin, for that well-detailed explanation, and I hope that has given you a great view and understanding of how to solve your problem. So if we have any questions with regards to the explanation that Kelvin has given us, we are free to ask, or we can raise our hand and then Kelvin will respond to any questions that we might have. Right, it seems we do not have any questions there. And looking at the time, we have now reached the hour mark, and this brings us to the end of our call today. And I would like to thank each and every one of you for joining us for the call today. Please be sure to join us again next week at the same time, 2 to 3 p.m. Central African time. And please, if you haven't shared with us your contact details, please do so in the chat. You can drop your email address, and then we'll add you to our mailing list so that we'll keep sending you updates from the Oxygen Alliance and reminders of when the next Oxygen Concentrator call is going to happen. Like I said last week, our final Oxygen talk for the year is coming up towards the end of the month, and I encourage you all to join us during that call because we'll have a very special guest speaker from AirSep. And for most technicians, I'm sure you know the brand AirSep. It's a very common brand. And we'll have the opportunity to ask all the questions that we might have with regards to their machines and how they go on about with their work. So please join us for that Oxygen Talk call, and we'll be able to learn a lot from the manufacturers of the machines. For those of you who missed our previous calls, our previous talks, you can find them on our YouTube channel. We always record the calls and upload them on our YouTube channel. So if you just search for Oxygen Alliance, you'll be able to find the channel and you'll have a chance to look at all our previous videos. And please subscribe to the channel when you visit it. And we also have a website, www.oxygenalliance.org. So that's where you also find a lot of other material that the Oxygen Alliance has been working on. So please visit these platforms and you'll be able to gain more information from there. So reaching this far, I'd like to wish you a great weekend, and I will see you in our next Concentrator Talk call. Have a great week, everyone.